This is a series on C for embedded systems. Subscribe to the channel if you have not subscribed yet. In this video, let's look at the address of operator in C programming. In C programming, the address of operator, which is represented by ampersand, is used to obtain the memory address of a variable. This is used to obtain memory address of a variable. The operator allows you to access the memory location where a variable is stored. The syntax is very simple. Let's say you have a variable, and if you put an ampersand before, that means you're trying to access the address of the variable. So address of a variable. Sometimes it's also called address of operator. Well, let's look at an example and see how it works. I have a program. I have a file called addressof.c where I've written this program. Here you can see that int num equal to 42. So we have declared and initialized a variable called num with 42. So using the address of operator to get the memory address of num. So how do we do that? You can see that I'm just trying to print the value of num in the first print statement, and in the second print statement I'm trying to put the address of num. So for memory addresses, like we will use percentile p to reference that, and you can see that address of num. So here I am just typecasting to void pointer. So void pointer is basically here percentile p used to print the pointer value, that means the memory address. Let's try to execute this and see what happens. So I'm going to take a new terminal. Then cd to source, and let's compile this. Gcc address of .c, and you can see that a.exe will be generated, and I'll execute this. You can see that value of num is 42 as it is shown in the print statement, and the memory address of num is, so this 0061FF1C. So this basically is not a physical memory, it is normally the virtual memory. Okay, so that's how the address of operator works. So as shown in the output, the int num declares an integer variable num and initialize the value to 42, and then %p format specifier is printf used to print the memory address in hexadecimal format. This is very important. And the void star is a typecast that is commonly used when working with the %p format specifier to ensure proper representation. Of course, even without pointer p, it works, but to have a proper representation, we use %p. So that's about how do we access the address of the variable and how do we print it. So let's see some use cases. When do we need the address of operator? So well, the first use case which I'm going to cover is the passing of values by reference. So the address of operator is commonly used to pass a variable by reference to functions. So this allows functions to modify the original value. This is very important. There are two ways to pass a value to a function. One is called by value, and another is called by reference. So in the pass by value, you're actually passing the value or the variable to the function, but when you do a pass by value, the value is basically copied to your function argument. But in reference, the address where the value is located will be passed, and when you modify the original value, gets updated. So let's look at with an example. So here I have a program to uh, use this pass the address of a variable. So here you can see that I have a void increment function, which basically takes the pointer to a variable, and we increment with asterisk x plus plus. That means the value that is stored in this address, we are incrementing that one. So that is how we have to read it. So here you can see that a pointer is a value that is stored in x will be incremented. And in the main function, we declare and initialize a variable num with 5. And I'm just printing before increment what is the value. Then I'm passing the address of num to the function. So here you can see that num has value 5, and I'm passing the address here. After the increment, I'm just trying to print the num, and let's see what happens. So for that, I'll compile this gcc address of passwordreference.c file, compile it, then a.exe. Here you can see that before the increment, the value is 5, and after increment, it became 6. So here you can see that we have used increment to modify the value that is present in the num. That means we pass the address, and that is what we are uh, trying to print. So for example, I just give an example of the same thing with just let's not pass the reference, we just pass the argument as a pass by value. So increment underscore value. So in this case, you can see that increment value, I will not pass the address. Okay, let me just compile it. And you can see that when you pass something by a value, the original value is not changed. Okay, I can actually print a statement here, uh, printf, and then let's just print it percentile x, sorry, percentile d, and then you have a value x. It's going to be printed, right? So then I'll just do a new line. You can see that. Now let's try to compile this and print it. You see, before increment is 5. This is basically this num, and I have just printed the value inside the increment or underscore value function, where we just pass by value. Here the value got incremented, so the final value after the x plus plus is 6. That's what I printed. But again, if you see if you come back to the main function, the value is not changed. So that means the value that we pass is just the num, and it's basically gets copied to the variable x here. So that's how it works. So well, I hope this is clear. Why do we use? How do we use ampersand operator to basically pass pass a variable by reference to a function? Okay. Now let's look at another use case where uh, to basically use this as to do a pointer arithmetic. So that means the address of operator is essential for pointer arithmetic, where you manipulate the pointers to access or modify data in memory. So we directly we directly modify the data using accessing the pointer to manipulate. So that's the use case. Let's demonstrate that with an example here. I have a function called I have a file called address of pointer underscore arithmetic.c, where we're trying to manipulate with the address of operator. We get the value of the array to a pointer variable, and then we do an arithmetic operator on the memory value. So that's how it works. So in this main function, we have defined an array and initialized uh, with 10, 20, 30, 40, and 50. This is an array of size 5. Then we have declared a pointer. To declare a pointer, you have star ptr, and to that, so it's basically pointer is a variable that stores the address. So what is a pointer? It's a variable that stores memory address. So pointer is a variable that basically stores the memory address. So that's what we're trying to do. Int star p is basically a pointer to a variable of type integer, and uh, and here the array is a type of integer, and that's why we can store the array bracket start with the 0 index. That means the first element of the array, that is address of that is basically stored in this pointer, and we are trying to print the value at the particular index, and let's see what happens. So I'll just do a gcc and address possibly not pointer arithmetic, and let's execute that. You can see that so at index I, that means at index 0 you have 10, 20, 30, 40, the value is printed. But here you can see that we are moving the next element in the array. We are not using this index operator here. We are just moving with we're moving to the next memory location using a ptr plus plus. So we just added the memory location, and then we move to the next memory location. So that is how we do a pointer arithmetic. So here is basically trying to go to the next memory location by adding 1 to it. So that's the use case. I hope it's clear. Now let's move on to the next use case, where we use the address of operator to basically to see the memory for debug and understanding memory layout. So the printing memory address and using tools like debugger can help understand memory layout of variables, aiding in debug and optimization. So this is basically useful when you have generate a .map file, wherein you have in the map file you have all the memory layout, and you'll also know where the memory where the variables are stored. So that information will come from .map file, and let's say if you print that, if you print the address of the memory address of the variable, then you will be able to find out whether it is in stack or BCC or a data segment, and all that information will be very useful when you're debugging the program. So that's about uh, debug, why we use address of operator while debugging. Well, so these are just few examples, and the address of operator plays a crucial role in many other scenarios where a direct memory manipulation or passing variables by reference is necessary. So understanding and using it appropriately is essential for writing an efficient and flexible C program. So understanding, in a nutshell, understanding address of operator is very important. So I hope this video gave you some insight into address of operator. I hope this is useful. Thanks for watching.
Subscribe to the channel for more projects, courses, tutorials, and tools.